Hello and welcome back to another LeetCode problem. We are looking today at an easy problem, number 976, largest perimeter triangle. And we're going to be given an integer array of numbers, and we should return the largest perimeter of a triangle with non-zero area, formed from 3 of these lengths. If it's impossible to form any triangle of a non-zero area, we should return 0. Then we have the constraints that we have at least 3 points in our list of, in our list of lengths, side lengths. So we should probably call nums lengths or sides. And it is guaranteed that there are no sides of length 0. We have at least a length of 1. Okay, cool. Let's have a look at an example. So here we have a triangle. The perimeter is just the sum of the length of the sides, which is 5. And yeah, and since there's only 1, that is also the largest one. So we return that. Next, we have an array where we have, I guess, if we just pick the 3 largest numbers, we should be good, right? So we could just pick 10, 1, and 2, and the results should be, 10, 1, and 2 can't really form a triangle, right? So that's not a valid triangle, because if we add those sides together, we have 1 long line, and the 2 short lines are not going to touch each other. And if we have a triangle where we pick the sides 1, 2, and 1, that would be a flat triangle, because 2 is the longest sides, and if we add the 2 short sides, that means they're going to be collinear to the longest side. So the area would be 0. That means we're returning 0. Okay, interesting. So that means that when we pick the length or the side lengths, we need to be careful that we can actually form a triangle. And furthermore, that the sum of the smaller sides are larger than the long side. All right, cool. So how could we solve that problem? Well, the naive approach would be to have an O to the power of 3, a runtime algorithm where we just iterate over all of the different indices in the array and check if it's a valid triangle. And if it is, we compute its perimeter and we remember which one has the largest perimeter. So that would be constant space but cubed time. And I wonder if we can do better than that. So if the numbers were sorted, we could try to find, well, we could pick the longest side, and we could then try to find we could then try to find the 2 short sides, and we could try to pick them as large as possible, such that it's still possible to form a triangle. So that would be an O of n squared times n log n time if we wanted to sort the array as well. And I guess we have to sort it to make that a little easier, otherwise we won't get away from the O queued runtime. So let me think, how would I implement the searching of a valid triangle in this case? There's a similar LeetCode problem, I think, where you just have to compute the area of the largest triangle that exists, or you have to count the number of valid triangle numbers, meaning the length of the sides. And so one thing that they do is, or that you do there, is you check if the 2 shorts are larger than the long side. So that's a condition that must hold. And if we assume that the array was in sorted order, maybe if we go through an example, maybe we can find out what a good approach would be. So if we sort them in this order, now what could we do? Well, we could pick the longest side first and then see if there are short sides that we can use. So what we could try is we could pick the longest side and its immediate two neighbors. And if that is already not a valid triangle, that means we cannot include the long side, right? Yeah, that is what that means. So if we pick the three largest numbers and it turns out the two shorter ones don't add up to the longest side, that means even if we pick shorter sides, we can't really do it. So maybe we can solve this actually in linear time, where, well, n log n time, where we just sort the array and then we just check from the back if we have triplets that form a valid triangle. And we always try to pick the one with the longest sides. So in the next step, we would try this one. However, here, the inequality doesn't hold as well. That means we can also not pick that. And then we run out of options, so we're not going to choose anything. What about this other example? So if we take the first one, we'll sort the numbers. And then we just pick the largest three, and actually the inequality holds. And we're good. So we can just add them up. Yeah, I think that would be a solution. So we would be able to implement this in linear time and all of one space. And we just iterate through the array backwards. So for I in range length sides, -1, -1, -1. And we have to make sure that we can actually pick three elements. So we have to correct this, I think, by +2. And now what we do is we just get the numbers out of the array. So that'll be equal sides from I -2 to I +1, isn't it? -2, -0, yeah. Yes, so that'll give us an array and we're assigning these values to it. And now we check if A plus B is larger than C, we're good. We're going to return A plus B plus C. And we keep iterating, and if we don't find anything, we'll just return 0. But we have to, of course, sort the numbers first. Sort. We can make it a little bit easier if we just sort in reverse order. We just set reverse true, and now we just iterate through the array like so from the beginning, because now it's a array in decreasing order. So we go from sides to sides +3. So we extract 3 elements. So I 0, 1, and 2. And of course here we have to subtract the 3 so that we don't run into any issues. Yeah, I think that is everything. So let's put this to the test. So getting the wrong answer. Let's see, why would that be? Are we doing something wrong with the index access maybe? So that would be another attempt before I start debugging output. Obviously I should actually know how to do that. +2. Okay, and I guess we're still getting the wrong one. So, okay. Yeah, so I'm just going to do a little bit of debugging. We're just going to print the sides. We're going to print the A, B, and C. And we're going to print A plus B is equal to A plus B. Right. Oh, now we have the order here reversed, so that's maybe the mistake. So we have C is the longest, B and A are the shorter sides. Okay, so we got this. So we're picking this side, that side. So A and B are actually larger than C, and we should actually return something. So why is it not working? So A and B. Interesting. So nums is, well, this is the sorted one. Aha. We have an off by 1 error, I believe. Yes. Okay, so now that makes sense. So the mistake was that we did -3 instead of -2, but yeah, now we have solved that. And both test cases pass. I'm going to remove the debugging output. Going to correct the rand to n log n. Space is constant because sorting in Python is done in place. And let's see. So there you go. That's the solution to this little problem. Be careful with your indices. Make it easy for you so that you don't have to do index acrobatics like I started out doing. And when you change your code to a different approach, you're really careful with you know, your variables if you're still doing it correctly. Actually, I want to see if this works as well. I plus 3. It should work as well. Yeah, so we're just taking a sub-array from the array, and then we're assigning those values to that. And yeah, that's it. So thanks very much, and enjoy implementing this one yourself.